Check, check.
Niin, jos tulee kyssäreitä, niin tää pitää tökkää tää mikki. No. Aluksi sanoo tervetulias sanoo. Joo. Ja tietenkin kaikki, kun tuolla on ihmisiä tuolla ulkopuolella kuuntelemassa, niin kaikki pitää tulla mikkeihin. Mä pitää laittaa nyt ne äänet oikein.
Check, check, check. Okay, we're starting in the classroom in less than a minute. Everybody can hear me? Yes. Nobody's here, but check, check, check. All right, welcome everybody, and this time looks like we are ready to start in time. Usually we take like a few minutes to let the last people in, but it looks like at least the room is full, so it doesn't matter if somebody is late. So, welcome everybody. So on behalf of DevOps Finland, I'm Timo Sturel, and happy to see you again here. And in the past we arranged these events kind of like once a month, but recently has been a bit of a lack of speakers. So if you have any kind of proposals for talks for us, so you can send me a private note in the meetup.com. You can find me. I'm one of the organizers of the event, and Pasi is the other one. Next one is basically reserved to the end of August, just because I thought that I won't be able to find enough speakers for event in June, and July is anyway a break for all of us. So, but anyway, that is currently empty. So if you have any proposals, they are more than welcome. And if there are more than 3 proposals, we are more than happy to arrange the next event as soon as possible after that. Yeah, and people who have been here before have noticed that I have changed colors. I used to have yellow hoodie. Well, that's past now, so I changed the employer, Actually, my new boss even promised to be here because we had this win-win deal that I'm allowed to keep arranging this, even though Vala is more like a test and quality company than DevOps firm. But well, then at last minute he had to down prioritize this event. So I think we need to discuss about the priorities with my boss. That he had some other event he had to go today. But hey, I don't have anything further. I give the word to our great host Nitor here, and then we go to speeches after that.
Okay, I don't have a slide set for you or anything, so I won't bore you for too long. Welcome to Nitor. Some practicalities. There's a toilet across from here, and when you go past the table in the kitchen, there's another toilet there, and then there's even one toilet when you go around the corner. Pizzas are going to be available as long as they last. We ordered for about 70. I think we hit that pretty close. So there's like about 2 slices for everybody, or roughly. Nitor is a consulting company. We do like systems for large Finnish companies. Like, did you get a permission to mention your customer? Yes. Yes. So okay. Samppa is working for Fournier, but we do Posti, OP, Nordea, S Group, Kesko. Anything from mobile applications to logistics systems and critical operations data for Fournier, for example. We also have an AI ML subsidiary that does data processing and maybe more traditional ML models, but we do AI stuff, obviously, like everyone else nowadays. Something is going to production soon, actually, for S Group, and we'll see how that goes. We're always hiring. For ops-heavy people, we have a subsidiary also that does support and maintenance. We just hired 2 new guys, and 2 summer interns are starting, so we don't have an acute need for anybody, but we're always happy to talk to people that are interested. So that also for dev-heavy people, then we have the creations is our main business. I think it's like 80% of our revenue. So we do mostly development by revenue by far. And like I said, anything from design to back-end systems to mobile applications to web front-ends and anything in between. So with that, I'm going to give to Samppa. You're welcome, and there's going to be a break after this, so you can fill up on stuff. Thank you. And if anybody has questions after the talk, please take a mic because there's people listening outside, so they won't hear you unless you have a microphone.
All right. I guess you hear me. Yeah. Hi, everybody. My name is Samppa Saarela. I've been working for Nitor 11 years. I started in IT business in the university, teaching and doing some internal stuff, 1999. So I have some experience of IT business already. Yeah, but about my background in DevOps, I've been mainly a developer. Before 2017, I did Java stuff with Spring Framework, basically like everybody else. Monoliths, simple to run, test on local, run on VMs, and yeah, virtual machines for CI/CD as well. That was simple stuff in a sense. In 2017-19, I started using micro-web frameworks. I liked them because they start up in milliseconds or 100 milliseconds instead of taking 10 to 20 seconds to start, like with Spring quite often. I abhor coding using JSON or YAML. So yeah, I also dislike writing logic using Bash. So I haven't really been doing DevOps or ops stuff before. Well, 2019 I started a project where we had serverless and all in AWS managed services. The serverless framework, that was pretty okay. Some other guy did the main stuff for it, but I was able to modify it for my stuff and for the add lambdas and do stuff like that. But since 2020, I've been like main responsible for also DevOps stuff. Yeah, and it was in the beginning. It was CDK version 1 with some Bash scripts for deployments, and since 2022 onwards, CDK 2 with CDK pipelines or AWS code pipeline. Also, I've used GitHub Actions to deploy stuff. So what I'm gonna talk first, I'm gonna talk about generic stuff. I think it was labeled adventures in feature environments. So I'm gonna define, of course, what I mean about feature environments. And generic stuff that applies pretty much to any way you wanna deploy these things. And later in this presentation, I'll also talk about how to actually deploy these things and my experiences of that. So what I mean by feature or branch or pull request environment? Well, the main motivation for is that the serverless architecture with managed services is really hard to test and run in local. And what I've seen of emulations, it's not really worth the effort. When you have multiple lambdas, if you have simple one lambda, you can test this pretty well using unit tests, but quite often features require multiple lambdas and other resources as well, in my experience. Also, lambdas are all about integrations. It integrates with API gateway and pushes to some other service or multiple services. So using mocks for SQSs, SNSs, nah. In my opinion, it doesn't really cut it. So also much of the code is about infrastructure, and it really needs to be deployed to make sure it works. So minor configuration details count, how you configure your event sources, is it raw message delivery, what are the timeouts, batch sizes, concurrency, all this stuff counts. And you can't really test it on local. So it's actually better to deploy the PRs to a reasonably isolated real environment. And of course, automate creating, updating, and destroying. That's really important, so I've emphasized destroying the feature environments. So why single dev environment is not enough, in my opinion? Well, to be honest, it works. If you have only one developer per project, it's okay. You know what you deploy there, you know what you're doing. But practically all new features require changes to infrastructure and most likely modifications to existing stacks. So while it's okay with one developer, if you have multiple developers pushing the same environment, deploying one developer deploying one stack, the other one another stack, you get really confusing results. You don't get a stable environment for one single feature on pull request. you might not even know what's deployed at a time if you deploy always from local one Lambda or something. So I kind of prefer pushing changes to GitHub and actually deploy that one feature in isolation from other PRs. So in a larger project, how many people do you say were in the developers in the project we worked in, Mika? 20? Maybe, yeah. So the feature environments, or we call them branch environments then, it was named in multiple reviews as the #1 success factor of that project. So reasonable isolation. You cannot really deploy anything in full isolation, even in cloud, unless you create new accounts for each environment. There are account level resources that must be deployed from single stack, for example, or set up for the account or region. Also, there are some resources that are better to share among multiple environments. For example, if it's something that requires long time to deploy, RDS database might take 10 minutes, 20 minutes to deploy Aurora. And you can share the same database between multiple environments using different schemas. Pretty easy. So no sense in deploying expensive, slow to set up resources per feature environment. Also, you need to have dev tools and, well, GitHub integrations, for example. It's good to have in once per account and actually only in dev account. Then also integrations. I've been working on projects where you get lots of events from external sources. Current project I'm working on has like 30 or more inbounds and even more outbounds. So to test something, we have this architecture that you have a reader that just integrates to the external environment and pushes the messages to a SNS, so that in the feature environments we can subscribe, for example, even from production feed. And so integrations making it so that there's one that handles just the connection there and pushes the messages, and then separate persister or handler for the actual messages is really, really handy. And those are good to share because, of course, you cannot call the integration partner to set up new integration every time you need for some PR. Some general recommendations. I strongly recommend using one set of accounts per service. Maybe dev, pre-prod, and prod, or just one. But I would not recommend deploying multiple services to the same AWS account. I don't have experience that much from other cloud providers, so it might be different, but yeah. The thing is that it's very hard to clean up stuff, and then you get all kind of possibly clashing names, resource IDs. I also would recommend monorepo for this kind of approach. Well, the whole back-end service at least is in single Git repository. UI has different dependencies, bundling and deployment, so that might be good to have in a separate repo maybe. But for the actual service that you deploy to cloud. Why? Because it's trivial to keep all the components in sync, no internal component versioning. It's easy to keep track of what's actually deployed. You have a single checksum, what's deployed where. You can tag it easily. Easy to make PRs, review them, features that span multiple layers of the software, and easy to orchestrate deployment. And yeah, again, about deleting environments, make sure you actively delete on unused branches. So just a disclaimer, what I'm going to present here, it's mostly about conventions, coding conventions, naming conventions, iterative improvement. It's not magic that you can apply on some project as an afterthought. You really need to, and it's better to start from the beginning to do it. So if you start the project small, you might think that, okay, it's good to have simple setup and do no feature branches because there's a slight starting price for it. But once the project continues to grow, you might be stuck with your choices later on. So yeah, proper tools and libraries can help a lot of things. I have created such libraries that I would really like to open source, but it's pending on, and actually I've gotten approval in principle already, but it's pending in company internal politics at the customer. Hopefully soon, any day now, any year. These things take time in large companies, as you probably all know. The 20% that is not just like coding conventions and naming conventions, is mostly about configuration management, which is important for these kind of things because you span environments every day, multiple per day maybe, create and destroy if you have a larger project. So there are different kinds of environments. One key thing is, of course, you have long living, pre-prod, prod, the main dev environment, and you have these short living test environments for pull requests. I use TypeScript as my preferred language, so whatever yours is, I would also recommend you coding the configuration as well. I've done my fair share of JSON and YAML configurations, but wouldn't go back there. What it needs is some way to derive an environment ID, and preferably from the branch name, because that's what you get when you create a pull request. You get a branch. But also good to have an environment variable where you can override the environment ID. And then you use the environment ID to get deployment configuration. And if not found with that name, and it is a feature branch, you can check it if it starts with F or feature slash. It's a feature environment, so then you can use feature defaults with minimal functionality enabled. That's one key point as well. But before that, about feature flags. So yeah, maybe 10 minutes initial deployment for some feature pull request is quite okay, but closer to 20 or, God help, more than 20 minutes is way too long. So at least in larger projects, feature flags in the deployment configuration are really useful. You can, for example, set enabled configuration if some features are enabled or not, and you can have the, for example, default SNS there in place in the feature defaults. And for permanent environments, it's good to have also this deploy disabled option, where you can deploy the infrastructure to be enabled later in runtime. It's quite handy to deploy new features so that you first deploy them and then you decide later when to actually enable them. Because, well, of course, anything can happen when you deploy stuff, but once you've deployed it successfully, then you can agree on specific date and time when you actually enable the features. Lambda concurrency to 0 and EVA source is disabled, but still deployed. In this thing, ability to merge configurations help. As a developer, creating a pull request, I want to enable only parts of the system that I'm actually working on. So there's a simple merge logic where you merge objects, well, simple way. You add or merge object array type properties and add or override primitives. But for arrays, it's good to concatenate arrays and do this deeply. And one hint here, if you make that kind of thing immutable, it's really handy for passing down, for example, Lambda property defaults from top down. You don't want to specify a Lambda architecture, bundling, and that kind of stuff at the lowest level, in the construct level. You want to pass them down from top configuration. If you want to change or upgrade your Lambda version or node version, you do it in one place, and then everything works. And this kind of simple merge algorithm is really nice with immutable results, where you can pass the Node.js Lambda properties, function properties from the top, and then at the lowest level just specify the entries and function names and whatever special properties they need. By the way, that's another library waiting to be open sourced any day now. Some configuration hints. I would prefer larger stacks over multiple small ones. It's faster deployment because resources are deployed in parallel naturally. You don't have to do anything to deploy stuff in parallel. There's less intra-stack references, which makes it much easier and faster to do modifications and, for example, deletion, destroying environments. I also recommend bundling Lambda functions if you have many. The project I've worked on, we've had like more than 100 Lambdas. And that's way too much for many of the cases. So it's good to bundle them into this kind of index file or lambdas.ts, which will speed up synthesis and synchronization because the asset building is synchronized process in CDK. So if you can minimize the assets that are built when you synthesize, it will speed up a lot. And it will also speed up deployment because there's less, for example, file assets in the pipeline or well, less stuff to upload to S3. And, well, there might be too many actions as well. This is, of course, well, especially AWS code pipeline specific thing, but there's like 100 actions per stage or 1,000 actions per pipeline. So I've actually hit those limits. More configuration hints. This is probably useful for any CDK project. Again, set the version reporting to false, or use the no version reporting CLI option to avoid unnecessary CloudFormation changes. I'm sure you all want to report to, I wonder if I can show this. Yeah, it's not showing, but you want to check that one out from CDK documentation. Whenever you deploy stuff, the CloudFormation reports quite a lot of stuff of your setup to AWS. of course, it's nice to help them, let them know what functions you use and or what constructs you use and what library versions you use and stuff like that. But it will slow also down the deployment. So and this metadata, CDK metadata resource will change almost every stack in every deployment. One hint again here. You may want to tag your lambdas with target concurrency. So target concurrency for the reserved concurrency, which will enable you to turn on and off lambdas, automate turning on and off lambdas at will. Quite handy. Add some tags there. Well, for example, I have a DB write tag as well. If I need to do some larger database refactoring, I can find all the DB write lambdas and turn the concurrency to 0, throttle it automatically. And once I'm done, I can revert the concurrency to the original value. It's quite handy, especially if you have lots of inbounds and components to be able to stop and start them at will. Yeah, there might be something like that also in the library if we ever get it open sourced. In my opinion, to make this kind of thing really work or fly, strict naming strategy is essential. And this is against CDK best practices, which basically say that you don't overwrite the name of physical name of stuff. But for this kind of stuff, I would recommend always overwrite the optional name in all main resources at least. Yeah, and in my opinion, pretty much everything comes down to good resource naming convention, because then you are able to find and identify environment-specific resources for troubleshooting and monitoring. It's easier to import shared resources when you rely on the naming convention. Also, you will always end up at some stage where some stack deletion destroy fails, and there will be some leftover resources. And you might not notice them immediately. There will be piling up these trashes over time, and at some point you notice that, hey, my CloudWatch logs isn't loading because it's loading over 10,000 log groups in the background before you can actually do anything with it. And yeah, having this good naming conventions helps you identify the log groups, for example, what are in use actually at the moment, and destroy all the others. Yeah, especially important for CloudFormation stacks, code pipelines, lambdas, SQSs, SNS buckets, log groups, the resources you use actively. I would recommend this kind of naming strategy where you have the environment ID, some delimiter, and local name. I've used this -- delimiter, and it works pretty well in most cases. And that's there so that you can easily separate between the env ID and local name of the resource. You can always search with the env ID -- and then you will get all the resources or stacks or log groups for that environment. You need to adjust it a bit, or I would recommend adjust it a bit. Use, for example, / as a delimiter for secrets manager or parameter store. And it's not allowed in database, no name, so use some other for that specific type of resource. And it's, well, easy as that. env ID replace dashes with low underscore, for example. There are gotchas here. There are quite severe name length restrictions. For example, NLB target group name is max 32 characters. So you might want to have a limit to your environment ID name. I've used 16 characters. That's quite okay. 20 characters is doable still and okay. And yeah, in some cases, some resources, they don't have name. Quite often they have names, and you can always easily search with a prefix of a name. That's, by the way, the point here. You can always, that's the prefix, you can always search by prefix of a name or exact match. Some resources allow you to search as a with a substring or some other, but the prefix is always at least supported. And yeah, I know some of you may be thinking that tags, you should use tags for these. But tags are not that handy. You don't see them in the UI, for example. For log groups, you can get tags for single log group at a time. So it's not even handy for when using the CLI tool to know which tags belong to what log group. So yeah, that's my reasoning why I use naming convention instead of tags. It's handy, basically. And yeah, there's some simple normalization logic for the NYD. If it's a regular branch, just take the branch name, and if it's something else, use anything after the first slash. If it has some weird name, you can normalize the weird name or abbreviate it. Yeah, this kind of weird naming convention or abbreviation logic where you remove all the vowels from the name is quite efficient and quite readable. But, well, of course it's better if when you create branches, you think about this thing. Refactoring is where you pay the price for using own names. Because refactoring resources may cause logical or physical ID conflicts. Some kind of changes require replacement. So if you modify some properties, that might actually require creating a new resource in the background. Also, if you change the logical ID if you change the physical name of some resource, you also need to change the logical ID because CloudFormation always creates the new resources first, and once it has succeeded in creating all the new resources in your stack, then it will just go on and delete the old ones. Basic safety procedure when you want to deploy something with minimal disruptions. One way of dealing this is that when you have to do some kind of thing, you can just add some version suffix to the names. And yes, this is probably the biggest reason why CDK recommends letting it handle the physical names, because it does these things for you. But yeah, in my opinion, the benefits of having proper names, good names for these kind of feature environments, and especially having these feature environments is weights more in the scales. And, well, refactoring the exported resources, when you, for example, refactor names or stuff, the CDK handles implicitly lots of exporting and importing. When you refactor stuff within a stack, resources that are within a stack, it's really smooth and you don't have to care that much. It handles things very, very well. But once you export something, and you might not even know when you export something because CDK does that on the hood. If you happen to use that same resource in some other stack, then it's exported and imported under the hood. by the way, only expose like resources that you actually intend to use in other stacks in the construct properties or fields to limit the blast radius. But in case resource is used in another stack, you might need two-phase refactoring. And this is actually regardless of whether you use implicit exports or explicit exports. The implicit exports will hit you even harder, in my opinion, because you don't necessarily even realize that you are exporting and importing stuff. But basically, CloudFormation doesn't allow you to modify any exported value. So if you need to change the exported value, you actually need to do it in this kind of two-phase refactoring way. So here's how it goes. You keep the old resource as it is, for example, the old SNS topic with some name, and you export it using this stack export value. Then you add the new resource there with new names, with the version suffix, for example, and you replace the references to the old resource in other stacks. Basically, if you have them in public fields, you can just have the new resource in that public field that is automatically then referenced in other stacks. But the important thing is to keep the old resource there. And then you go on and deploy to all environments. And this is important. You need to deploy to all environments so that you won't get in trouble later, especially production environment. Because after you have deployed them to all environments, then you can remove the old resource and deploy again so that the old resource, deprecated resource, is actually removed. But if you, for example, do this second phase before you have deployed to production, you will your production deployment will stop. It cannot deploy stuff because it's trying to remove a reference that is in use in another stack. So destroying old environments, as I've told many times already, is really important here, and it's probably the most difficult and critical thing of this kind of approach, because over time these trashes pile up. They will make eventually AWS console practically unusable. They incur costs. And they break builds once the resource limits are reached. Everything is limited in AWS at least. And there are some hard limits that you cannot even configure. Some limits you can, but some not. So it's better to keep things clean and clean up your trashes. And yeah, sometimes you need to delete stuff separately because CDK destroy fails, and this, it's good to monitor the feature environment cleanup also and see that the things get cleaned up nicely, and also when you have to do it manually, the naming convention should help. So nowadays, the CDK destroy with proper configuration is really good. It can empty S3 buckets and destroy S3 buckets, if I recall correctly nowadays itself. But there are still leftovers. There are implicit log groups created by lambdas, created by code builds, and those need to be handled. And log groups also, if you have APIs, the REST APIs will create log groups with obscure ID in the name. So one hint here is that it's not that hard to build a tool, Lambda or CLI tool, that in the dev section of the system that lists all log groups, lambdas, code build project, and APIs and so on, then compares those to the existing log groups, what is active at the moment actually, and deletes if something is not actually used or in. And well, if you have a database, then the same way some tool you use to create the schema, you use to delete the DB schema so that the database won't blow up. One note here is that the process that runs the destroy, it technically can be part of the environment being destroyed, and that is quite simple and handy, but it's not optimal because there will be leftovers using that approach. For example, code build that destroys itself, it will leave its own log group there. And if it happens to delete before it's finished, it might leave other resources there as well. Any questions at this point before moving on to deployment stuff? Well, yeah, that about deploy automation or continuous deployment. I think there's two main ways of doing this, using shell script or bash script, using CDK deploy there with GitHub Actions or code build project. Or you have pipeline. I would assume that other cloud providers may have something similar to AWS code pipeline. Don't know. I'm mainly talking about AWS code pipeline and especially CDK pipelines tool. So the CDK pipelines can now handle bundling and uploading assets very well, and using bash is actually a very straightforward option for small and simple projects to deploy stuff. You have GitHub Action that just does the CDK deploy, and easy and simple. But it's fast for small project, but for large projects it will be prohibitively slow because it does things in sequence or manner, and it's really hard to parallelize the stuff that CDK deploy does. Back in the days, we used bash script to run code build project, run in a code build project to deploy stuff in parallel according to this proprietary configuration. And it was really hard to maintain. The orchestration and error handling in bash is not very simple. For example, you have only one system out. How do you output stuff to system out from multiple parallel processes? We ended up doing stuff like piping the logs of each process to a file, and then after everything has finished, outputting each of the files to the system out, in the end, CloudWatch log group. But yeah, if the the error happens in the first of the line, that's somewhere tens of thousands of lines above, and it's really hard to find the error and debug it. And well, in my experience, bash is pretty hard to handle errors in bash. You have all kinds of flags that affect how the errors are handling, and at least I have trust issues with it. So with pipelines, you can have TypeScript logic, if else for in CDK code to actually define what stacks are. Actually, yeah, depending, you can always have that. So either you have them without a pipeline or you put them in a pipeline. But let's talk about the pipeline a bit later. So yeah, so CDK pipelines, you put your stacks in a stage that is in a pipeline, and the the pipeline is added directly to the app. The CDK pipelines, it does stages automatically for you. It has a source stage that will get from, for example, GitHub, the source code, and build, which basically does the CDK synth. And then it uploads assets automatically in parallel. And there's this update pipeline check. It restarts itself. If the pipeline is modified by the deployment, it will restart the pipeline again to run with the new configuration. In earlier projects, we had self-modifying code build projects, but it was sometimes a bit confusing when you push something and your modification comes in effect in the next run, not the run that you're actually deploying it. But it's nice that CDK Pipelines does that for you. It notices if the pipeline has changed and restarts it automatically. Automatic parallelization, it's easy to debug and monitor each step of the execution, because each step is running a separate code build project, and they have separate log groups, logs and so on. So how to do it releases with this kind of things? There's two approaches again. You can have, for example, different branches with each having separate pipeline. And in this kind of branch per release environment, you usually force push to some production branch to trigger a release. This is pretty handy for hotfixes, for example, because you can just check out the production branch and do your stuff there, commit, and it will automatically deploy. I find a bit more cleaner approach to have a main pipeline with stages for these pre-prod, prod, whatever environments you have after dev. And then tag the release. Then you have like single source of truth in the main branch of your GitHub repo, and it's a clean flow always from feature branch to main to pre-prod and prod and so on. And it doesn't require any nasty force pushing. Also, if you use force push, it's really easy to forget to cherry pick the fix you did for production. You need to cherry pick it for your main environment as well. And it's really easy to forget to do that when you have pressure to fix some bug, preventing some or fixing some production issue. For pipeline stages, as a rule of thumb, I would recommend having, at least for larger projects, shared and app stages, and optionally maybe dev tool stage, which is only deployed for development environment. So basically, the shared stage is optional and deployed based on deploy configuration where all the common and shared resources are. And you have to use explicit CFN outputs there, because you cannot export. The implicit export of import of CDK doesn't work across stages. So you have to export stuff using CFN outputs. And when you export them using the env-ID as a name, then in your application environment or app stage, you can just have this shared environment ID to use to import the shared resources. Security groups, secrets, database, whatever. And there's FN import value, or some resources have this from XSF, from secret name or something that you may be able to use directly. But it's easy with this shared env-ID and naming convention. And this kind of thing also allows you to deploy multiple full environments on single account for even better isolation. For example, penetration testing environment, we just did configuration and deployed it to pre-prod account in full isolation, so that if the guys doing the testing actually succeeded in screwing up things, it wouldn't actually mess up other environments. So the deploy configuration, when using this kind of approach, you will have basically deploy configuration per the environment ID, and then of course the feature defaults, merging and stuff. But this is a set of common properties I use for deploy configurations. So manual approval, if yes, then it adds the logic that creates the pipeline based on the configuration. That's this manual approval stage or precondition, pre-action to the pipeline. Maybe tag release, if you have a Lambda that will create a GitHub tag or Git tag. Maybe next environment, if you have this single pipeline from dev to prod. So you have next environment ID and you generate the pipeline in a loop. You start with the current env ID, you make the stages for that, and you see that, okay, this stage will have next environment that, you get the deployment configuration and make the stages for that stage, and so on. Maybe termination protection to safeguard your production environment is a good idea. And then the optional dev tools stage, if you have something dev tools you need to deploy, the optional shared stage configuration, and if not, then shared env ID as an option to that, and then the actual app stage configuration where all your business logic should be. About the dev tools for GitHub integration, for example, it's good to have, for example, code build projects to create and destroy an environment. So it's a code build project, you have good name, create environment, and the other one is destroy environments, feature environment. And the other one has CDK deploy, the other one has CDK destroy. So quite simple GitHub project, code build projects. And then an API Lambda to receive, for example, GitHub webhook events for pull requests and issue comments is quite handy. When you create a PR, you trigger the create code build project. When you have close event from the PR, you trigger the destroy code build project. And in this way, they are separate from the actual feature environments that they are destroying. So there won't be those leftovers I was talking about earlier. Then optional but nice, I'll show a picture soon, is to have, for example, GitHub status notifier or status notifier. Maybe some custom resources or lambdas to comment some build details to pull requests. For example, dynamically generated API gateway URL is handy if you don't have a domain. And maybe some logic to create a release tag. Here's a setup we have in my current project. We have the source, build, what's that? I cannot see, assets, all these default stages, and then it starts to deploy actually stuff, shared stuff, and then there's dev or main shared dev app stuff, and then there's E2E environment shared databases, E2E logic app stuff. Then there's manual approval for pre-prod. Pre-prod is single stage because it doesn't have, it uses the same database as E2E from here. And then there's a prod approval, manual approval stage there. And here's some examples from the GitHub I mentioned also handling in the webhook handler, handling comments, so I can write /environment deploy comment there, and it will trigger the create code build project, or environment destroy. If something goes horribly wrong and you need to get rid of the environment, you can just put the command there and it will trigger the destroy for that environment. Yeah, sometimes it's easier to just scrap the feature environments to rename things, for example, than doing the tedious two-phase refactoring for your feature environment, pull request. Yeah, and this is also comes from the build pipeline custom resource that will send this kind of comment to the pull request. All the pull request with the build status reporting will show how the build works. There's minor thing here. I haven't figured out yet a way to make those FIFO, those events FIFO. So I actually handle all the success of the actions or the steps there, because otherwise you might get pending after you get the success, and obviously you would have pending state here for eternity. You could do, of course, something nicer to check what's the latest status and not report pending after success. And then this is, for example, in the main page of the repo where there's this green dot there. You can click on it and it shows how the main pipeline is succeeding or not. You can see if it's pending some E2E manual approval or so. Again, these things you see here, they're pretty small lambdas, I would say 100 to 200 lines of code. So not really that hard to do yourself if we cannot get the library open source, but yep, I hope we do get those kind of tools are included in the library. There are some gotchas here, especially with the CDK pipeline. There's a couple open bugs that I consider pretty nasty. When doing destroy with the CDK pipelines, you need to do a bit of a hack, so you need to get stacks to destroy using something like this. List all the stacks and then destroy the stacks. You need to name them, otherwise it will only destroy the main pipeline stack. Another, this is actually really severe in my opinion, bug in CDK, in CDK and CDK pipelines. Basically the pipeline and or stage name or the ID is included in some resources logical ID. So if you have deploy my main environment, in the stack you will have deploy my main environment prefix to the logical names of the resources. And as I mentioned earlier, if the logical ID changes in CloudFormation, it will destroy the old and create a new. So basically, the stacks you create using these CDK pipelines, they will be tied to your, at least some resources. If maybe you manage not avoid that kind of resources. In the bug, there's a list of resources that are like that. But the stacks you make like that, they are tied to the pipeline or stage you use or to deploy them first time, basically. So you are kind of stuck with the pipeline once you start using it. As I said, I consider this quite severe bug in CDK. But of course, they cannot fix it, because if they fix it, it will change all the logical names of existing stuff, and it would actually have to be an opt-in fix where you can start a new project with a new, better logic to deal with this thing. But luckily, there's one way to at least limit the blast radius for these. In the first project I used this CDK pipelines, I added all the stages to pipeline and then the stacks to the stages as like CDK children, like the regular way you would do it. But actually you can use the app as a scope for the stages of a pipeline. So you can add stages to a pipeline without them being children of the pipeline resource in CDK tree. So you, instead of when in the stage of in the pipeline code, instead of creating a new resource with this as the scope, you pass on the scope, app scope from above. And in this way, you will have like, stage-dependent stacks, which is nice since now you can, for example, deploy a hotfix pipeline. If you have to do really larger hotfix for production thing, you can create a hotfix pipeline for production environment only and run the whole pipeline to deploy the fix. Of course, hopefully the hotfixes are only for some specific stack and you can just deploy it manually from your local. But if you add the stages with the pipeline as the parent scope, you would not be able to do even that, because once you create a new pipeline with a new name, it would destroy everything and create everything again. So I guess I'm hopefully not too much over time. Yeah, a summary of the benefits of these feature environments. You will have well-tested, fully automated deployments already before you go to main, or already before you merge to master or main. The infra code will be properly tested even before, and you can have that as a gate before merging any pull request. A successful build is the configure. Also, your feature can be properly tested in real life. And yeah, in this way, you don't have to synchronize deployments with any else developer. Each PR can, or each developer, of course, you can work together on some PR, but then you work together on it and you work on the same stuff in the PR, and then you push to the same branch together and merge your conflicts and so on. But yeah, it's easy to handle and manage. And yeah, no need for complex local setups to emulate managed services. You actually use the managed services as they're supposed to be used. And yeah, it improves quality, simplifies, and speeds up development. That's all I have to say, unless you have questions.
Actually, one question.
Yeah. Hey, just wait. So we have people online, so whenever we have questions, wait till you get the mic.
Perfect. I actually ran here to be able to ask a question. You touched RDS databases briefly. How do you actually manage data? Because if the changing environments touch the data, then it pollutes, in quotes.
True.
So do you always create a new database schema for
Yes.
the environments?
Yes.
And just load in data?
Yeah, if it needs to load data, then yes. In a project, I've actually built my own data schema management tool, and I have simple conditionals at the start of each migration script to define if some file is included or not. So I have, for example, basic reference data in this kind of like conditional migrations where you run them only in feature environments, not in the permanent environments, because that would be bad, of course. But yeah, one step I've used like custom resource lambdas to run the schema migration easy, but of course there's this 15-minute limit there, so not optimal, but I'd say 95% of the migrations should run in 15 minutes because you don't want to have longer service breaks, for example. And after, as a destroy the custom resource drop schema cascade.
That was the question. Thank you.
Thank you.
Yeah, and like this guy did, so if you're sitting in some other room here and you have questions, you need to jump up from the sofa and come here.
No, thanks. Thanks for very fascinating speech. Two questions. First one is how, you decide what for the shareable resource, is it to use outputs or SSM parameters?
What's included in the feature flags?
Yes.
Yeah. I define that in deploy configuration. So, for example, pre-prod deploy configuration, there I have the basic configuration, what is enabled and what not, and also the deploy disabled option, where if it's true, as I have in pre-prod and or basically all the long-living environments, I can basically in the CDK code check if deploy disabled or the resource is enabled, or the component is enabled. Then I can deploy the infra to where I want.
I'm asking because we faced with certain problems. So if we're using output parameters, we tightly couple the stacks. And we need to redeploy stacks if we also stacks if we change something. So using SSM parameters, we more about orchestration, more about not.
The runtime. If you mean the runtime configuration, so basically, we did use SSM parameters also for enabling, disabling stuff in runtime. And then you have to deploy again, of course, and you will have to have some modification to the parameter name to make it effective. In this case, I add the configuration, what is default enabled and what's the target concurrency directly to the lambdas. And then the runtime configuration is a comparison of whether the lambda is throttled, if it has concurrency 0, and what's the default value configured for that lambda, which is found from tag. So does that answer your question? Yeah. So
second question, a bit related to the first one. Do you have any, for feature flagging, do you have any naming convention, how you manage this life cycle for the feature?
The feature flags, in the sense I've meant here, are feature flags for the infrastructure and deployment, mainly. And the main goal is to minimize the time to deploy new pull request environments and control what is deployed into which environment. For example, you have some long-running stuff that needs to be tested multiple months in E2 environment before you can deploy it to production. Then you can just configure the production so that it's not actually deployed there before time.
So it's more configuration. It's not a feature flag.
Yes, but of course you can. Sometimes your UI is dependent on the feature flags, of course. In which case, some of the infrastructure, and they are intertwined. You need to have some API endpoints for some feature in UI. So you actually will probably need those feature flags exposed to the UI as well. So I don't know, maybe you can, I've used different tactics here. In a project where the UI was in the same GitHub project, There was a kind of preprocessor for the index file that added the feature flags from the deploy configuration, the relevant feature flags directly to the index HTML. Another option would have something like profile endpoint in your that will expose the feature flags from Lambda environment variables, where you set them up in the CDK. So yeah.
All right, thank you. We are running a bit late, so let's thank Samppa now. If you have more questions for him, so you can do it during the break, and let's have a 10-minute break and then continue with the next one.
Thank you.
All right, people, let's continue. Showing yellow light there, and there's a switch which turns it on. Isn't there here? What does it say? I didn't see the text.
I don't have my reading glasses on.
Ah, there's a mute there, and
Yeah,
now it's on.
We've used several times this nested stack, but
yeah, if you
more
we can slide it off.
it solves it.
Now it's off. Yes.
But that means that if I do like this, all I need to do is to switch it on.
Ah.
I will just get.
People, as said, we will continue. Please have a seat. Well, maybe I trust that we don't have the room full now, but hey, yeah, if there are people who want to join us in the main room and didn't fit in for the previous presentation, now there is lots of space here. So feel free to come here. And by the way, like I mentioned, well, Vala is more like a testing and quality company, but that if you are into testing or quality side, so we were selected the best workplace for 2025 in Finland in the mid-class, mid-sized companies. So, and we are hiring as well, like Nitor. So, but yeah, we are just testing and quality. Not that much DevOps things, maybe a bit, but anyway, good to mention it here because next presentation will be about testing APIs or not testing APIs. I'm not too sure. Maybe Victor will tell us. It's still yellow. No. Slide.
Sideways.
Yes. Now it's working.
All right.
All right. So, Victor, please. Testing APIs without API tests.
Thank you. I just need to do one last thing. I need to get internet here in case I want to run away and show something else. Whoops. This is not what I wanted to do. Okay. Before we start, I wanted to do one thing that we don't do very, very often here as an icebreaker, and is to thank not just Pasi, but also Timo, for the work he's doing in terms of arranging this meetup. So please, let's give him an applause. And the green color fits you very well. Congratulations. So yeah, in the previous presentation, we were told like how cool and how easy it is to create these kind of feature environments, right? I want to be even more disruptive maybe and ask like, do we even need them? Can we do it in a way that, I don't know, maybe the previous presenter had something else to do? I don't want to say that, but I just want to bring a bit of a disruptive talk today, especially since the weather outside is pretty gray. It's May, it's still plus 3 degrees this morning. So anyways, I hope you can bear with me. My name is Victor. And typically I start with presentations with this question, like, why are you here today? I don't want this to be really like, just me talking. So maybe if you can help me with the microphone, why are you here and you are not outside enjoying the +6 degrees on the street? Or even better, on the comfortable sofas of the other room, right? I mean, you are here like this will be, I don't know, a classroom.
They told me you put a good show, so I'm here.
But that's a lot of pressure.
You asked.
All right, let's see how do we end up here, all right? But nevertheless, how do you test APIs without writing API tests? Can you even do this? Yes? Okay, at least one person is on my side. I feel like I have 99 against me, right? No, the fact is, like, if you think about, like, I don't know, a car, say Mercedes, right? I mean, actually, we build Mercedes here in a place called Uusikaupunki in Finland. You know where is that? My wife is coming from there. I need to do a bit of commercials here. So, will you test that the steering wheel works only when it's assembled in the car? Or will you do some other tests, before you do that? Do you need 1,000 cars to test 1,000 steering wheels? Maybe not, right? So that's a bit the question here. So first of all, who are we? We are Ritchie Bros. Does anyone know Ritchie Bros? Excellent, right? Well, this is basically what we sell. I've been different places. I was in doing other things. Now I sell tractors as a service, or I do tractors as a service. We are an auctioneer, so we sell second-hand big machines. So if when I was working in Escaupat, I couldn't sell tomatoes, and that will mean thousands of euros of losses. If I don't sell all these tractors, it's not $1,000, I tell you, right? So it's a bit more difficult. We are like worldwide company, even though originally from Canada, big presence in North America, 8,000 people all over the world. And Ritchie is in Finland because there was a Finnish company called Maskus that perhaps somebody knows. It's a listing company for big machines, so like Tori, but for tractors. And this company was acquired 8 or 9 years ago, right? Just to understand where the orange color comes from my presentation. Our locations, China, India, North America, Finland, when it comes to engineering, which adds certain complexity to this mix. And that's a bit the reason of my talk. And why is that? Well, we have those locations. We have a large system, legacy things, tech stacks, on-prem, in cloud, different clouds, different regions, you name it. And I wanted to kind of start my presentation with throwing a simple question. What problems are we trying to solve? We talk about testing APIs. What's the biggest problem you may have when you are testing an API? First one, they tend to be flakiness at times. They can be brittle. Like we spoke earlier, you may have an API that is going to talk to another service that perhaps on that common environment, because we are not that cool that we have these feature branches, maybe down on the other side, or even maybe your only QA or test environment is under provision or is used for multiple purposes, or somebody decided that on Tuesday at 10 o'clock it is the best moment to do security testing or performance testing, and UAT is down and nobody can test that. Has happened to you, right? When was it, this week? Well, it's a real pain, right? Then, it may sound a bit obvious, but to test an API, you need to deploy it somewhere. And that may feel very, very simple because we have this pipeline that we got presented earlier. But actually, it's not that simple. I mean, like 20 years ago, when I started coding, it would be just myself writing something locally and push it somewhere with an FTP and that's all, right? But there are certain questions, like when do we deploy it? before, after pushing to main branch? Are we in trunk-based development, or do we have another branching strategy? Or do we have an ephemeral environment that we've been presented earlier? That means a lot of work from somebody like Samppa, for instance, right? Doesn't come out of the box. And what happens if we have pushed to the main branch and those API tests fail? Do we do a rollback, or, what does it imply in terms of our delivery capabilities? API tests typically need test data, so they are not out of void. So, how do we create that data? How do we delete that data? What happens if me and Alberto, we are trying to update the same service, the same API? Do they both clash at the same time? And perhaps all that time that goes to do that kind of management could be used elsewhere, in my opinion. And then, as I mentioned earlier, your API provider could be someone working out of Denver. So if you have a problem with your API, you need to reach that guy. He's going to be first available at 3 o'clock finish time, when you actually need to go and pick up your kids from the daycare, right? Or, we're trying to use an API that, someone is provided by someone on the other side of the world, and that's our reality, right? Because we have folks in China, in India, in North America. We have really, really limited kind of like common time with them. So, reality check first. How many of you have been developing APIs? Any front-ender in the house, because you are also back-enderish? One person at the back. I mean, go higher, it's okay. Even me, I have been doing the front-end, even I suck at design. But at the end of the day, when you are doing back-end development, and by the way, has anyone worked with contract testing before? Half a hand. Well, you work with me, so half a hand. You work with me, and you'll be working like 2 weeks, right? So a couple of people, right? Cool. But basically, when you are developing an API, your natural feeling is going to be this. Just deploy it and test it with Color Postman. Just like throw it there somewhere, and I mean, you don't need to laugh. It's just, all of us, we've done it sometime, right? I said, in my presenter notes, it's like, just deploy it and I will test it with Color Postman, said no backender ever, right? But in my worst case scenario, I'm going to run a pipeline to deploy an API to the cloud environment to realize that it does not work for reasons outside of my control, like the underlying service is down, or the infra doesn't work. And the dude who can help me lives in Montreal, and then when this thing gets fixed at 6 p.m. my time, then something else happens and that person is in Wuhan. So that's what really is a pain to us. And then kind of the same case, but on the consumer side, and for us it really sucks when we are blocked by problems that are outside of our control, right? And
but I mean, isn't that easy case? I mean, kind of, you are in Finland, you find a problem, the first person to do the first fix is in Montreal, and the next one is in Wuhan, and next morning everything is fixed when you start working again.
I mean, in an ideal case, maybe, but by the time that fix is in place, I already woke up because my kids are small and they wake up early, and I found a second problem, right? So, but yeah, it's typically like that. And the real problem here is like our inner dev flow is broken. And being this the DevOps meetup, which by the way is one of my favorite meetups here in the Helsinki area, I wanted to reflect on this reality when it comes to something that I hope is familiar to at least a few of you, and it's the famous or infamous 3 DevOps ways. And the first one, and this is, it was, I think, created by Jim Kim. The first one is the idea of flow and system thinking, right? It's the idea of like emphasizing the performance of the entire system as opposed to the performance of this very thing that is happening right now. So we as engineers, what we want to see is flow, is things moving from left to right. We want to deliver, we want to experiment, we want to bring things forward, right? We don't want to be stuck on the place where we are until Mike wakes up in Denver, or until, you know, a person in China wakes up, or, you know, you don't want to get up at 6 a.m. to be able to catch up at 2 a.m. or 2 p.m. in Wuhan. And this development flow, when it comes to API testing, can be enabled by contract testing. So what is contract testing in brief? The idea is that we ensure that there are two, here the definition is like software components, but I always like to talk about a consumer and a provider, like say a front-end app, say our auction site or our mobile app, and a provider, you know, a backend API. We want to make sure that we can communicate correctly. So basically, that steering wheel that we want to put on that Mercedes actually fits and can move as many, you know, as wide as it's meant to move, you know, and we both parts know what's expected, right? I know how wide it can go. I know, you know, how many years should live, et cetera, et cetera. For me, in simple terms, it's like an expectation management in the world of software development. Technically, they are called interactions, what we're going to define as these states, right? But what I want to make sure is that me as a consumer, my expectations, the interactions that I'm going to perform against a given provider will be fulfilled, and the provider should make sure that whatever they publish in this contract telling like, yes, this is what I'm offering to you, is going to be respected. And how do we manage this? Well, basically, there is a quite famous framework called PAC framework that helps you to create these contracts that are basically JSON files. And sorry, somebody talked earlier about JSON. Sometimes JSON is good. They are JSON files, like it will be a contract, right? Like, I mean, I bought a car on Friday, and, you know, I got a piece of paper telling that the expectation that I pay this much money, and, you know, my expectation I will be the owner. I will be able to drive it. Then once we have these contracts in place, they will be published to something called a PAC broker. Can be like Packflow, the most famous one, which is a, you know, commercial platform, but, you know, there's also like an open source version that you can basically install on your server if so you wish. And probably you could even implement PAC, like contract testing in a more like, I would say, handmade way, because we are just talking about JSON files, right? So let's say, and this is a bit AI generated because now you need to put AI on everything you do, that you have a consumer here, say your web application, your app, your mobile app, or even another backend service that needs to interact with all these other services. So what are the problems typically you're going to face when testing this, when having this in production and trying to evolve it, when trying to make changes, etc.? Anyone ever here? I mean, you are all backenders. The front-end guy, you can stay quiet now, but I mean, everybody else. So if you hear this guy wants to make an update of the service, how does it know that the consumer is going to be happy with it? Do you go to Wuhan and say, hello guys, we are going to do this? Has anyone been in a situation where you are just going to a Slack channel telling, hello, we are trying to introduce this change to this API. Is everybody okay with it?
Make it backward compatible.
Said no backender ever, right?
Let's make a new version.
Let's make a new version. It's really good. It's really, it's a perfect. It's really good. Okay, so you go, you know, you actually go with what? With a V2? Perfect.
2.1 to make it more confusing.
Exactly, or alpha or beta or something. And then you realize like, oh yeah, we're gonna make this new version and this cool. And then somebody else says, yeah, well, if we have a new version, we don't need the old version, right? And since we don't need the old version, we just forget that we have a mobile app distributed to, say, 120,000 people.
Or even better, a TV set. it's impossible to update.
Exactly. So that may or may not have happened to us quite recently in terms of like, we want to make a change to an API, or we wanted to make a change to an API that didn't have versioning. First mistake. And somebody said, oh yeah, let's just put V1, right? So that we can evolve it later. What happened? The native mobile apps were using the non-V1 version, right? Actually, we caught this issue with contract test, so it never made it to production, but it could have made it to production, right? But this is the reality that happens, like in a microservice architecture, you're gonna have this situation. We have a consumer with 8, 10, and this could be like, I don't know, a GraphQL talking yet with another API down the line. From the provider side, what's expected here? From the provider side, the only thing here is just to make sure that the endpoints offered by you are doing exactly what you are saying that they are doing. And the risk here is that there is a disconnection between that contract and the real implementation. Have you ever been in a situation where you have an open API spec and you change the implementation of something, but you forget to update the open API spec? Been there, done that. So there are certain things that you can do in order to verify that your open API specification or your service, they are doing exactly what is meant to do. We'll get into that later. And you can actually, when there are changes in the consumers, you can use webhooks to kind of trigger this kind of test so they verify that with those new expectations that we were talking earlier, you are still like not breaking the contract and you are still on a good shape. But typically the flow will start from here. Me as a provider, I offer this. And if you are not just a backender, but actually a proper backender, I will say, and you treat your APIs as products, this is something that it should be really, really important to you, right? Like, this is my product, this is my API, and should be stable. Then what happens on the other side? On the other side, you're going to have all these consumers defining the expectations, right? Me, as the core service hub, when talking to that API or to those APIs, my expectations are this. And how do we define that? Well, instead of actually calling to that API, we will mock that call. But we will just, capture what's the expectation from my side. And we are going to just put that as a JSON file on that broker so that, we can capture every single piece of consumer in this setup, all those expectations, right? And then in our pipeline, we could have a step telling, can I deploy? Am I actually respecting everybody's expectations? Typically, that's going to look something like this. This is something that I taken from the tooling that comes from Backflow. Like I said, it is a commercial solution, but that's what we use. But basically, you have this consumer, you have this version, and then you have different providers. Every one of them having a different version of the contract. And what you are doing is basically matching that there is success on all those interactions. So you know that no matter how many agreements you have in your system, they are always all in sync, and you can proceed, maybe deploying to your application to QA or to production, etc. So if I go there, why does my flow as an engineer get unblocked? Why do I embrace the first DevOps way? And from the product side, I don't need to reach out to everybody to say, is it okay if I do like this? Right? I can just produce a new contract, and everybody will be testing that contract. So it's kind of like, I don't know, when your electricity provider will go and tell okay, now it's going to be more expensive electricity. They don't ask any single of you, right? I mean, they just send a note this is happening. I can make faster calls in terms of API version that you were mentioning here earlier, right? I mean, if I do a new version and I run that against the expectations from all consumers and everything is good, I can proceed with that. And typically, if we want to do that kind of like development in terms of like going V1, V2, etc., you will produce a new one, and perhaps you're going to give like a deprecation notice, like V1 is going to be deprecated by this time. One thing that I feel extremely important is like I am in control of my API, right? I mean, I don't need to depend on other people. So, I don't need to depend on somebody in Denver or in Wuhan to support me. And I would like to say that this is almost like a philosophical question in terms of testing, right? When you are testing an API, why do you want to test it live, running there? What does it bring you? Because with modern frameworks, when we are deploying to an environment, all we get is some kind of scaffolding. And many of you probably use something like, I don't know, Spring Boot or something. The real meat happens in the service layer. Everything else is just kind of like boilerplate to be able to access that. Someone like Alex will start talking about security. Yeah, I can buy that point. Like maybe you want to see it. How is that, the security layer applied when you deploy to a given environment, things like that. But all the time that you save executing those API tests or investing in those API tests, you could actually invest in your local sort of like service testing. I can replay all these expectations. I can just go and understand why I am existing. Once again, if you provide an API as a product, it's cool to understand that there's actually somebody calling me. There's actually somebody who wants to use my API. Has any one of you developed an API that was used by no one ever? Right? How cool is that? And yeah, like I mentioned, I can allocate more time for comprehensive unit testing or service testing or component testing. And here is where the real business value is, in my opinion. For the consumer side, I have an automated way to communicate to my provider. This is what I expect from you. Have you ever been in a situation where your front-enders are very coupled to your back-enders? Like, can we have a 30-minute call to discuss how this API should behave? Is it familiar to anyone? I typically say that it's cool to do that because we are all friends, but in the moment that somebody's in Wuhan and we are here, we are not that friends. Well, we are friends, but you know what I mean? We cannot get maybe that 30 minutes to discuss exactly that. It's way better to formalize it as a contract. And basically, I don't need to rely on that API being up and running in order for me as a consumer to test. I can just rely on my contract test and then just mock that call because I know that they are going to provide that. Second way, amplifying feedback loops. So it's about creating the right to left feedback loops. Well, for me, the idea of this amplifying these loops is like, I don't need to have that API there in order to test it. I can get that loop, that information loop even faster. I can get that information, and did I break something, it's going to be okay, et cetera, way faster. So it's kind of like being snappy in terms of development. I can, notice this kind of breaking change earlier before I deploy or even merge. In our case, we do pure trunk-based development, so I'm pretty happy to run this before I push to main, so I don't like block my pipeline. I will understand the impact of changes, and I will understand what are the expectations, right? Has anyone been in a situation where you need to reach out to another team so they will add this new field to this API because we really need it for our, right? So you could just formalize it. It's like, from this expectation, there are these two fields that are missing. And for me, this enables like this shift in testing left because you can do this from your local machine. You don't need to, I don't know, go somewhere, deploy something. It's just on your machine or on your CI/CD pipeline or exactly in the same way. So it's really replicable, right? And like I said, earlier testing meant more time for actual investment in business. Third way, the culture of continuous experimentation and learning. And this is like what I typically will call the story time, right? So how have we kind of changed our culture by embracing contract testing? So not couple, because even though it's still gray outside, is spring now. But somewhere in January, February, I was engaging one of our teams, and we were creating this new API. And there were like infinite discussions on what this API should do, which storage we should have. Let's chop this feature in 3-4 slices. So, one guy takes one, the other one takes another one, etc., etc. Been there, done that myself. Ends up like what? A lot of like merge conflicts. At some point, maybe 1 week down the line, we get to a sort of solid commit. And the question came like, so what do we do now? And what was the answer? Anyone? Not yet. Just deploy it somewhere and we test it with Postman, right? And there I thought like, no, we don't do that because we have other ways, right? And one of the things that we were doing here is like, okay, there's a bunch of business logic happening behind that API. Running out of battery? No. Can we do something else than deploying it? Can we actually invest in a different way? And since it had a DynamoDB there, so can we do something that actually uses an in-memory DynamoDB to just use it as a storage like layer whenever we are testing this logic? And that's what we did. So first thing there. Then we started thinking, okay, but this logic is there, but still I want to make sure that our API is doing what it should. Okay, let's write this contract test. And they did it. And they wrote 1, and they wrote 2. And actually, there was a moment where the QA engineer in the team and one of the backend engineers sat together to define, one of the front-enders to define how are we going to call it, the consumer expectations, right? And then they pushed the expectations, and the guys on the back end, they were like, actually, I don't need to figure out how to test my API, right? Because I have already these expectations here. So can I replay these expectations against my own backend? And the answer is yes. But they didn't do it on a deployed API, on a deployed API service. They did it against this in-memory database. So basically what we did was to decouple, front-end and back-end, but they still keep all this testing as unit tests, essentially, plus this layer of contract testing. I don't call it exactly a unit test, because for me, a unit test is something that you should be able to run locally without connection, but here you need to reach to the broker in terms you need to have some connectivity, right? But basically, what I'm seeing from this team is like, instead of just having these eternal discussions on how to break this API, how we're going to build it, etc., they go API first. So first they will create the API. They will think about what this API needs to offer. Then they will create these expectations where they will engage. They are pretty coupled still, right? But that's okay because they sit in the same location. That's fine. But as they continue thinking, and that's the cultural change, it's like, okay, we have these expectations, but can we go even further? Some of these people came with a framework called T cases to create, more like a larger variety of test cases based on that API specification. And at this point, I can say that API is pretty well covered. It's really realistic. And one of these guys said, the cool thing is like, whenever I need to change this API, I can just run all this on my machine. I don't need to reach out to no one, right? So that was a bit the story I wanted to bring to you. Do you have any questions, either here or on the comfortable sofa rooms? I think over there.
Yeah, any questions?
Right, so is this working?
Is there a microphone? Sorry.
Yes. So, whose responsibility it is to make the contracts? Clients, and does everyone have to use the same contract system?
Obviously, that's the point. Like, you know, like everybody will publish the contracts to the same space, so that whenever you have this kind of topology that I show, where you have like one consumer and several providers, you can even see this. And if there are broken contracts, like I said, we use Backflow. That's a commercial platform, but you see what is broken. You know, what consumers' expectations are not met, or things like that. In terms of being an API provider, it's your responsibility to publish the right contract. And that was one of the risks that I mentioned, right? Like at times, it could be that your API specification in terms of NOS specification is not realistic if you don't keep it up to date. And that's one of the things that I believe is pretty important, right? Like, how do you publish your open API specification? And there are tools to actually generate code based on that. And there are tools to generate, or to do the other way around, you know, to generate the API specification based on the code. But as a provider, it's your responsibility, and as a consumer, it's the same. So it's not cool to use your API without you noticing, right? Has anyone been in a situation where we changed something on our API and whoops, it broke something, and you are like, but what you were calling us, right? So the responsibility is shared in a sense. But your responsibility as a provider is yours, and the same on the consumer side.
So this tool cannot be used, for example, to mock or verify compatibility with platform APIs, such as if my provider is something like Salesforce, and somebody changes the Salesforce schema, the API responses change, but they can't probably use this kind of tool.
I don't really know if Salesforce have something to, you know, there is a packed framework for Salesforce, or there is a way to do that, right? We use a front-end, like, no-code platform called Retool, and one of our questions was like, because it's a typical platform that you can just like drag and drop UI elements to build like fancy kind of UIs. So one of our questions was exactly like, is there a way to create these expectations, you know, from that tool? We haven't found it yet. This is more for, you know, the situation where you're actually building and writing your own code.
All right, thank you. I think someone else also had.
Thanks, Victor, for the talk. I heard about Pact from like many years ago, but never seen it anywhere in use. What would you say is the trade-offs? Like, when does it make sense, and what is the cost of taking contract-based testing into use?
I like, you know, the thing is like we are really into platform engineering, so we have a strong sort of ways of doing things. Our backend applications are pretty alike all over the place. So then it makes sense because, you know, you can just introduce this technology and everybody will embrace. If your, say, topology is a bit more different, you know, like you have different types of services here and there, and then you need to understand how can I produce this test, you know, with my PHP application or something. It may be more costful, you know, but if you are really like kind of homogeneous in your topology, I think it's a good idea. The drawbacks, I think, money. So, you know, it costs some money to use this kind of tool, or otherwise, if you're going to host it yourself, you need to have some, you know, someone in your organization managing the broker, especially, because you want to keep this place somewhere. I believe the framework provides CLI tools, etc., so you can do these comparisons and things like this, but it's going to be up to you.
I see. And then the overhead is maintaining these contracts from the consumers and producers.
I don't see it as an overhead. I see it as an investment. You know, like I think like it's basically like instead of, I don't know, deploying somewhere an API, building this API tests with, I don't know, REST Assure or something, and then making sure that the test data is in place and all that. I think actually, in terms of time, makes a lot of sense. It's more like a cash question in my view.
Yeah, thanks. Anyone else?
So can we automate the flow of contract testing?
Sorry, can you repeat?
Can we automate the flow of contract testing? For example, a new build comes in the environment, and I want to check if it really, before we go for the testing, and we can test it.
Yeah, I can tell you how it's our setup. So building the application is one thing. The contract test that comes with it is a different thing. But they are basically at the same level on the API. So, everything needs to go green before actually deploy to dev environment. Actually, when I came to the company, all that was like a big box. So what we did was to kind of break it down in independent steps, just to, shorten the time we wait in terms of pipeline time. But that's how I will do it, right? Yeah. In a classical API testing, what you will do is you will do your build, your unit test, then you will deploy to some dev environment, then you will run the API test, maybe have some step to manage the data, right? So here you do it before you deploy.
More questions there?
Thanks for your talk. You mentioned that essentially if you develop API based on some spec, like OpenAPI spec or some other like standard spec, it seems like that it's actually a contract, right? That needs to be enforced.
Mm-hmm.
Okay.
Yeah. And it's especially important if you're in different locations, or like if you have your consumer being a television or I don't know, a stick or something.
So are there multiple versions of this contract so the backend can decide against which contract is testing? For example, there are multiple front-end developers developing different features, and they want to change the contract. So the front-end developer will block the backend basically until all of the contract is fulfilled, right?
So what you are saying is basically, can we have a car with 3 different types of steering wheels? I would recommend. I think it's a very good question, right? Yes. What at least the framework support is the idea of creating a contract for a given environment, right? So you can just publish this contract for dev, publish this contract for QA, or even for your feature branches probably that you, right? So then the contract can also evolve as your code evolves. And the cool thing is no matter where you are in terms of at what stage, that code should respect that contract. But I think you have a different organizational problem if you have too many steering wheels and just one car.
More questions?
Does it work with GraphQL as well? And the schema is more dynamic, more complex there? How?
We don't use GraphQL. I used it in the past. The typical feedback or the typical question I will get is so what we are doing here is schema checking. It's not exactly like that. This was just a bit of a high-level presentation, but you could get into more the nuances of what does it mean and what are we really checking when we are creating this contract and checking this contract, right? Because you could just say this API is going to return name, it's going to be a string, or zip code is going to be between this value and that value. So, it kind of goes more into those small details, but I don't have personal experience in terms of implementing.
Maybe GraphQL already solves the problem by itself by having the strongly typed schema, and you can define the types very clearly, and then you have the problems in the next step of the integration of their data sources against the GraphQL schema that will be published and connected to another integration level.
One thing that is very important is when we talk about this consumer provider idea, we think about a customer-facing application and a backend, but it's also very important in a backend-to-backend communication, right? So a bit what you are touching.
Any integration.
Correct. I think you have a third-party provider, you were talking about, was it Salesforce, right? And they would provide this. This is what we support, and this is the contract. Just run it against your implementation. That would be cool.
Cool, thanks.
Yeah, I have one question. So I was just wondering that do we have any needs to think about how to do testing better? Because AI is taking everything over and we don't need to think about it anymore.
I think like AI is not taking our brains quite yet.
Yeah, I kind of I saw an article kind of where it was put pretty nicely that thinking about the current AIs is that the AI, you can consider AI as an assistant that is really kind of productive, resourceful and efficient, and it needs to be micromanaged.
The thing is, like, if we bring that question to our context today, right? I mean, contract testing and things like that, you know, we could basically have an AI generating billion of consumer cases. Like, oh, that open API is there. Let's try all these possible permutations, right? Boom, 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 boom. Well, somebody's going to need to pay for the time that it takes to run all those cases in the pipeline, for instance. So I think it's our job as professionals to put a brain there to define what makes sense. And something I mentioned down here in one of the slides is like having this kind of automation enables more time for us to support our business. And that's, you know, where I think that the AI can be a tool, but actually, you know, in the field of testing, it is a tool that, I don't know if it needs to be micromanaged, but at least, you know, we need to put some kind of like, you know, proper thinking in how much of it we want to introduce. And you know, does it really resonate with the real case of our business?
Maybe the edge cases are good for unit tests, not for the high-level test of the API.
Perhaps, but even on those situations, you know, like, I see that real cases where you just want to, you know, you may want to reach a certain level of coverage, 80%, 90%, something like that, and you use an AI to do that, and you get a lot of like unit tests that just touch the branches, but does that mean anything to your business? I always tell this story, right? I mean, like, back in the old good days when I was still living in Spain, I worked at the university as a, you know, like, maintainer for the labs, you know, and one of my users comes and says, like, I have a problem with my floppy reader. I am that old that we have floppy readers there. So I go there, and yeah, when I try to introduce this floppy to the reader, it doesn't go in. So I open it, and what I found inside was a chorizo sandwich. So never underestimate, you know, what your function or your unit can take and how can react and how that can affect your whole system, right? So AI for unit testing, maybe, but remember about my chorizo example next time.
All right, thank you, Victor.
Thank you so much.
Yeah, let's have a 10-minute break before the last talk today. Nyt se on päällä. All right, people, please come in and let's continue. I kind of like the setup what we have today. So first we had some cloud talk, then we had a testing talk. Now have some platform engineering. And I think it's a pretty rare that we have had any book reviews here. So this is kind of an experiment as well. And probably at least something I would like to see more in the future. So because there are lots of interesting books, but we are rarely having any reviews of those here. Yeah, and by the way, lots of space here in the main room, yes, so welcome.
Yeah, okay, seems to be working.
Yeah.
Mic.
Mä en muista, onko se Mike vai Mike?
Se riippuu kielestä.
Saa valita.
Yeah.
No niin, se on vähän niin kuin tää sun ex-kollega sun arkas. Onko se Jacob vai Jacob?
Niin, täältä kotona on Jakob.
Joo. No. Yeah, so our last speaker today is Mike or Mike Vainio, whatever you like it, and so he is reviewing us this book, Platform Engineering from Aurelian. And yeah, please.
All right, thank you. Yeah, so the book was published, I think, November last year. So Platform Engineering, a guide for technical product and people leaders, by Camille, Fournier, and Nowland, just to give some credit. So, it's pretty hard to find any pictures of myself, but here's one. I was working remotely, and my co-worker here, Raffe, was a bit hungry, I think, so I got this picture. So some stats about me. So we have 3 cats. That's one of them, 2 kids, and 1 wife. Then about the book, I kind of split this into 3. So first let's talk about the book, and I try to kind of keep my own opinions a bit out of it, so you get an idea what's said in the book versus what I think of it as much as possible. But of course, I'll only talk about the things I liked in the book. So. Then I give some final thoughts, maybe a bit beyond the book, but on platform engineering. And then maybe we have some time for questions, but interrupt whenever, ask questions. Yeah. So I have this kind of special slides every now and then where you can see a chapter number. So that will kind of help me as well to keep track where we are. Not that we're going to cover every chapter, but helps a bit to keep track on what's the chapter of the book we're talking about. If you later look at the book. So the what and why of platform engineering. So what? So a definition. Definition is nice. So a platform is a foundation of self-service APIs, tools, services, knowledge, and support that are arranged as a compelling internal product. So I think this was adapted from some other post in the book, but nice of them to give a really clear definition. And we'll talk about all these things in more detail. But then the definition of platform engineering. So platform engineering is the discipline of developing and operating platforms. The goal of this discipline is to manage overall system complexity in order to deliver leverage to the business. So I think the most important word here is that we want to deliver leverage to the business. And luckily we have like few more words, not an exact quote, but basically leverage is that work of few engineers reduces the work of the greater organization. So basically, like, you go to your boss, like, we're going to do this platform thing, I'm going to do the work of everyone else. And your boss is like, yes, great, Mike, as long as you don't want to get paid more. That's fine. So that's what we want to do the work of other people, right? That's great. Oh yeah, but why? Why should we do that? Well, other than that we are like really nice. So basically now we get a bit technical. So they're basically saying that we have this sort of a problem in our hands with the infrastructure. So, so the book kind of focuses on kind of like infrastructure and your like development tools, pipeline tools, whatever, or like, you know, your like DevOps role. Typically you deal a lot with like cloud infrastructure and Kubernetes and whatnot. So that's kind of the focus area of the book. Because I guess like, you know, you could build different kinds of platforms and the word is used in a lot of contexts. So yeah. Anyway, so cloud adoption. So it maybe didn't quite go as advertised by the vendors. So a lot of companies have been like sold the promise of a PaaS, you know, platform as a service. In cloud, you don't have to like worry about the infrastructure. You just like deploy your stuff. Like sure, if the serverless stuff works for you, like that's exactly how it is, right? But in reality, a lot of folks, a lot of companies, especially at some scale, they're forced to accept the reality that, you know, they're going to have to use the infrastructure building blocks there to really make it work for them. And then Kubernetes, bit of a problem as well. So basically a leaky abstraction. So it allows you to like kind of hide a lot behind the Kubernetes APIs, right? You have all the interfaces there. You can have different implementations for your network and storage and whatnot. But to actually like configure it correctly, like that's not trivial. And if you just give everyone Kubernetes, then you're like exposing them to this leaky abstraction where they actually do need the in-depth knowledge to really get it right and configure it correctly. So Kubernetes like really hasn't really solved, or is just like adding to the problem basically. All right, so they have this special word, so the glue. So basically they're saying that we are in the swamp that consists of glue. There's a picture next so you can see it. But basically, yeah, so the cloud and all kinds of open source software you might be running to kind of like, I don't know, deploy your apps or whatever, infrastructure pieces. You have this huge amount of general purpose building blocks, and each team is probably going around and doing kind of their own take on how they're going to use all these general purpose building blocks when they like deploy their app, or their app needs some infrastructure, a database, S3 bucket, whatever. They're going to configure it their way, each team. So this stuff is basically the glue, but there's also a definition. So glue is integration code, one of automations, configuration and management tools. So that's glue. It's not super exact. Thing with this book is there's like, it's really high level. Like it said in the title. So it's basically our subtitle. It's for leaders, you know. So there's a bit of a lack of like tell me exactly what you mean, dude. There's a bit of a lack of that, but that's fine.
What are one-off automations?
Yeah.
Things that you run once but automate.
Yeah. Yeah, that's, you know, keeps me busy. Yeah. Yeah, that's Okay, so there was this picture in the book of like the glue. So down here we have like the general purpose building blocks, right? Oh, this is like the swamp, I guess, and the glue is like there, and this is like how things are connected to each other. There was like more of these blocks in the middle in the book, but I just removed them because there's no like real explanation of what they are. So I felt like a bit confused what's going on there. But you can see, you know, each and every application has their own glue. They have their own set of dependencies and stuff. They configure it a bit everywhere. You know, this thing in the middle is maybe trying to help, but in the end, like, you reach to them, you maybe get something from here, and you still go there and configure it anyways, however you want. There's really no like governance here. So the idea with platforms is we put them in the middle, and then no more going down here, unless like a bit of a special case. We will still go there. You know, it happens. Like, let's be realistic. But basically, the idea of platform engineering is that we put these platforms here. You use the platform. The platform has like opinions, whatever, on how to do this thing below here, and this then, you know, will help with some things that we will cover next. Oh yeah, and like now basically like the glue code really shrinks as well. So it's not just like, you know, that there's a bit of a mess with like what connects to what or what depends on what, but also the glue itself is now kind of not gone, but you know, it's basically now in the platforms in some ways. The pillars of platform engineering. So there's 4 pillars. Product. What are really the pillars? Well, whatever. The kind of important things about platform engineering, I guess. So product, taking a curated product approach. So platform is a product. Development, developing software-based abstractions. Breadth, serving as a broad base of application developers. Because if we don't have the breadth, we don't serve a lot of, you know, users, customers, then we don't really have much leverage. So it doesn't really work. And then operations. So yeah, there will be operations in the platform as well. It's not just like we give something to someone and that team's gonna like own the whole thing, but we're gonna really like run the service as well. So the development stuff is basically like, it's like you build a backend, there's an API, doesn't have to be like a REST API, can be like, you know, message brokers, whatever can be used there, but you know, REST API is of course the classic example. But yeah, we built this thing that like sits in front of the like general purpose things. But of course, you know, once you maybe provision something, then you can like get maybe an S3 bucket or whatever, and then you go there. You know, you don't always go through the API. That's something they say in the book that's like not obvious always to people. It seems like pretty reasonable to me. And they have this bit of a hot take. If you're not writing software, you're not doing platform engineering. Okay, yeah. Yeah, this wasn't like the opinion time, so that's later. Oh yeah, they also say that, just want to comment a little, because basically everyone's talking about these portals like, yeah, whatever portals. So that's not really like, you don't really need, by portal I mean like a UI, right? Something to put on in front of your platform, like that's the platform because like that's what people see first. But that's not really a requirement for a great platform, because like if you don't have a backend, then you don't have a platform. So like, don't start from like the portal necessarily, unless you're just gonna have a platform that's just like metadata or something. Okay, chapter 4, building great platform teams. This is pretty interesting. Oh, I have a picture. Okay, so surprise, surprise, the culture is platform engineering. Then there's like 2 focus areas, roles, whatever. Well, role is here. 2 focus areas, software and systems, and then the roles. So, well, there's basically the software engineer role, and this would be like your backend engineer, you know, deals with APIs and integrations and stuff. And they say in the book this would be ideally a candidate that's really interested in like how systems work, a bit like how operating system kernels work, how databases really work, and that sort of stuff. So really like, yeah, in depth in the. And then the systems path, there's basically like systems engineer, bit of an odd like a title, but this is basically like your DevOps generalist dude that just does like everything. And this is like kind of, these 2 roles are what you really need, and then there's sort of more special roles, so system specialists, so there you can have someone who's like, you know, knows all the databases inside out, or knows some specific database inside out. You know, you have some sort of kernel dude or whatever, performance dude. And then reliability engineer, so obviously like operations was part of this. One of the pillars was like running it, so yeah, we want to have someone to really like make sure that it's engineer the reliability. But yeah, someone to look after that as well. Well, not just one person. So as you can probably see from this already, like we're talking about quite a dedicated team for the platform. So this really isn't for some small organization, and that's also like the thing. Like if you're not like writing software, you're not platform engineering. It's because like, you know, this is not for like a company that has, you know, few developers. This is someone where you have like 100 and more developers or engineers. That's the kind of the scenario here. And in the book, there's like a short couple pages on like for smaller companies where it doesn't make sense to do this. What should you do instead? And it's basically like kind of building up to this in a sense where you do want to have your dedicated software and dedicated team. So they say that there's sort of like 2 pitfalls with the team. So you might have a team with too much system focus. So they're great operationally, but they don't really have experience of building complex software, right? Quite obvious. So they focus on building automation scripts and the one-off tools, the tools you only use once, instead of architectural changes and building abstractions. Yeah, anyways. And of course, you know, everyone's biased to like hiring more of themselves. And you know, software engineers don't really like being with these guys, like with me.
So this is your DevOps team, right?
Yeah, this is your DevOps team. Yeah, they could never build a platform. No, I mean, then there's the there's the other side. Too much software focus. So they love nerding on new things that will solve all the problems, current and future. And they get really frustrated when they get handed some legacy code. So basically any code they didn't write. They just want to build something new, innovative, something that will solve everything. And they're really bad at estimating. So they think they're going to make it, but probably like the platform's just going to get scrapped before these guys will actually deliver anything. So you want to aim somewhere between these 2 extremes. Yeah, and platform as a product. So this is like one of the core things. So compelling internal product. I think that was in the definition of what is a platform. So there's this point they make that you have to build compelling products. Like, you know, the point of the platform is to really make the lives of the greater organization better by you suffering in the platform team. I don't know where I would like to build this honestly anymore. But yeah, so one kind of important point is that a business, they're building a product. They can't really make the customers to use the product. So why should we do that internally? Because I've seen this firsthand as well. Like, if we build something, we've spent so much engineering time on it. Now everyone's just going to use it. Like, you're going to use it no matter what. and that probably looks good if you're tracking like your adoption metrics or whatever. But yeah, we shouldn't really do that so that we can actually get some feedback on the platform. Smoothing the edges. So there's kind of this point. I think this comes back to kind of the systems engineers or the DevOps engineers, that they might be just like forever, like they'll make it work. They'll build another one of script or maybe two of script, and they miss the bigger opportunity to really like rethink, build something to really solve the problem at its core. And this is probably where you need kind of the balance of the software engineers, where they see the opportunity that like we could like hide this thing there and then just like not show it to the customer, and it's like good enough if we do it like this. Let us handle the thing in the back end basically. Yeah, and then like customers versus stakeholders. So product management is not about making the most important person happy. So this is kind of a problem with an internal product. There's like these people with suites often. They can be a bit like problematic because like they might want you to build something, and it's quite easy to just say, yeah, we're going to build that because like the boss said so. But we should really listen to the customers, what they want, understand their needs, instead of that one very important person. And this is like a problem with internal things because, they have some power over you, right? But there's like a lot of stuff on managing stakeholder relationships. That's one of the chapters in the book. So let's not get too much into it. But yeah, operating platforms. So I think they have a good point here. So stability is mandatory. I think everyone understands like you start using something and it just doesn't work half the time. You go and deploy, it doesn't work. You're frustrated. You lose the trust. You're just like, I'm not going to use that platform. That platform is shit. So seems pretty obvious, but I think you could kind of ignore this. You could be like, yeah, we're just figuring out. We're gonna force these migrations every week. Yes, Jacob.
Well, I think a lot of the time when building platforms and you use third-party tools, the platform team blame it on the third-party tool, and I think that's when this is really relevant.
Yeah.
Like if you're running Artifactory, let's say.
Yeah, that's right. Yeah, they should. I mean, some sort of vendor engineering is in central of this, right? In a bigger organization, they're using a lot of software that's from third party, and you just have to own that shit as well, because it's like if it's not working, it should be your problem as well, not just the customers. Planning and delivery. Well, it's just kidding. No. All right. So everyone loves being agile and whatnot, but like planning, doing a roadmap, really like communicating that you're gonna really deliver something is like a big thing in the book. So there's a whole chapter on planning. So it's kind of like waterfall stuff in a sense. It's like water scrumfall or something. But it's it comes back to the stakeholder stuff. So basically, like you need to have a plan in order for someone to keep funding this internal thing, because the value can be really hard to measure or kind of impossible. Honestly, it's hard, and even measuring it takes a lot of effort as well. So yeah, but I'm not gonna go into like how you should plan it, because it's like what kind of platform is it? Can't get too much into it. But there's some advice, like what sort of documents you might want to create and whatnot. Yeah, like one thing they actually do mention on this topic is kind of like doing something like ADRs, like architectural decision records and stuff, like really showing like how things gonna be built, and then taking it further than that to an actual action plan, I think they call it in the book, like how that's gonna actually happen. Yeah, and then re-architecting platforms. So they have one pretty interesting take in this chapter. So the re-architecting work is kind of like this is like this moment is when like you have a platform and it starts to like take off, like it's working, it's solving a problem, and now you're kind of like maybe software was a bit rough, maybe it wasn't optimized to do the right thing and so on and so forth. So you need to make some changes. So it's easy to be just like, okay, now we have like the product market fit, whatever. We know this is the thing we should build. So you just say like, well, we're going to put the V2. We're just going to start from scratch, just build the exact right thing that we now know is the right thing. But they basically advise against doing this because then you're basically introducing multiple mindsets in the team all at once. So what the hell is this mindset thing? Now borrowing a bit from Simon Wardley, so he has this concept of like 3 sort of mindsets, or he just calls it a concept. So you have the pioneers. This is like the very first stage. They create all kinds of crazy things, or they have crazy ideas. They build things that doesn't necessarily always work correctly, and you can't really trust what they build necessarily, but you need them because they have the best ideas. And then comes the settlers, sort of phase mindset. So they take that half-baked thing from the pioneers and make it something useful for larger audience. They build trust and they turn it into a product. And then there's the town planners that kind of like now it's really like really adapted widely in the organization, and now we're looking for economies of scale and just making it better and better and good enough. I think it's a good thing here. Like the platform doesn't really need to be like perfect for everyone. Good enough is really like that's as good as it can get. Like that's good. It still like probably saves a ton of time for everyone. So they're not maybe loved that much anymore, but this is the different mindset. So basically, in the book, I think that people can change between mindset. Some people like outside the book, like Simon Wardley has this thing. Basically, like some people kind of feel like they fit into one of those in some way. Obviously, kind of like one of the extremes, right? They feel more connected with those. So they have this point that they think people can change. They can, switch between the mindsets a bit. But it's really challenging when you mix the mindsets at the same time. Like when you're building the V2, you might like get this idea to really change things in a way that maybe that makes the platform easier for you to operate or whatever. It makes things easier for you, but actually the customer is going to have some way different experience with the software, and it's going to be like, what the shit? So yeah, so you can go a bit crazy with that. What's the next slide? Okay, this is the last one on this. So basically what they recommend instead is to re-architect, which is kind of like, it's like the hard way. You just keep grinding with the same code base, just like keeping the APIs the same, more or less, just like grind it out, change the things you can change, make it scale, make it performant. A lot harder, right? Because you can't change all the parts of the plane when it's already like up there flying. But
to throw questions.
Yeah.
So this you mentioned before that the book was saying about smoothening the edges.
Yeah.
Is bad.
Yeah.
Isn't that the re-architecting? So
V2 is kind of breaking new ground.
I guess they mean that like now we can smooth the edges because we already know that like it's working. Maybe. That's maybe, now it's okay to make it a bit better. But maybe the smoothing the edges, it's also like, kind of like, it's not really about performance or stuff. It's like really like, it's just the wrong shape. It doesn't really work. I don't know.
Smoothing the edges was more about like, we could take the microphone.
Yeah, just take it there.
Yeah, so the question was like, isn't re-architecting the same as smoothing the edges? My understanding of smoothing the edges was more like, I don't know, take a Terraform module and you make it a bit prettier for the users, whereas this is more like, okay, we have an API-based provisioner or something, and now we would re-architect the back end of that provisioner. So to me, they would be very different things, but I might have the wrong understanding of smoothing edges.
Yeah, sorry, I don't really like remember the context there too much to answer. But yeah, I think Jacob might be onto something there. Migrations, sunsetting. Oh, you had a question?
If you go back to the previous slide.
Yeah.
Even more.
Even more?
Like, here. So it says pioneers are brilliant people, but they can't build something working.
Yeah.
Do you agree with this, and what's the source of this?
Source is there. No, but this is there's actually like more things in the blog post if you go and read it. But I mean, it's just like, I guess, Simon's being a bit dramatic here. Like how can you prove that it like solves the problem if it doesn't work? I guess it's more like it doesn't like work always. It's not super stable or something. That's how I think about it. Good point. All right, migrations and sunsetting platforms. Not gonna talk about sunsetting because that's like happening already. Ease migration pain for teams. So it's like it's mentioned so many times in the book that migrations like suck. And again, the platform thing is gonna take the hit. So platforms help with migrations because it minimizes the glue and the variation with the abstractions, and it allows you to architect for transparent migrations. So by transparent migrations, I mean like migrations that the users don't even know happened, right? So it's so hidden in the backend, they don't know it ever happened. Like you update some versions somewhere, and that API doesn't even change. Why should the user know about that? That sort of migrations we could do. That's not really a migration, this is an upgrade. But anyways, track metadata, who's using X, but this is not really free. I mean, obviously, someone interacts with your API, you might have to like store something somewhere. So you like have some data, but like in the book, there's like talk about having like a specific sort of registry for like metadata, like what teams you have, what sort of, I don't know, identifiers they have, and so on and so forth. So you can really like make these connections between a piece of infrastructure and who owns that and this sort of stuff. But it's not exactly free. And then there's like a bunch of these chapters. It's pretty funny. In the book, I didn't even mention it, but there's like 3 parts of it. And the part 3 ends here between the 10 and the 11. But it feels like the author didn't really, like that was just put there like after the writing, because it's kind of like it continues. All these 3 chapters are kind of about stakeholder relationships, just like, what if you have a competing platform? There's so many organizations, they're also building a platform, solves the same problem, because they're so frustrated, they can't deal with you. These sort of things, kind of like, this might happen to you, a bunch of stories from the authors, like the kind of shit they faced, and that sort of stuff. And aligned, So here's the really like, here you can see more like what really happens in like a big tech company, where there's really like kind of competing things. It's about the alignment in a sense, and the trust as well. Like, you know, someone doesn't trust your platform, they're going to build their own platform. So you can get into all kinds of messes there. So there's a lot of like I don't know. There's a lot of words here, but it only applies in certain cases, certain contexts. So I'm not going to really cover it. Yeah, the last chapter of the book, your platforms are loved. It's just like that's what it says there, but then it kind of says that your platforms are probably not like loved really. So building platforms is hard, and I think it's hard because of like all this people stuff, not really the technical thing. Because like, yeah, more on that next. But even a highly successful platform might not get much appreciation, because like how often do you like go and like hug the guy who keeps the Git running? You know, you're like Gerrit instance or something. You don't go there like, thanks for hosting the Gerrit. By the way, can we use GitHub? But you know, because chances are the platform is only good enough, so people are not gonna be extremely in love with it. So what's the point of building one of these? Oh yeah, and then like this must be like the last or the second to last page in the book. They give like bunch of shit to Terraform. So so let me just read this so you don't have to. So while the cloud vendor and OSS ecosystems have accelerated technical innovation, they haven't made the software systems any simpler than in the 90s with servers as pets and proprietary vendor platforms. The frustration has shifted from dealing with data center engineers to grappling with the copy and paste nature of Terraform code bases. But the complexity remains. So, you know, of course they had to put this to like the last page so that your average DevOps engineer isn't gonna like just throw the book away. So yeah, they're kind of arguing here at the very last page that kind of this Terraform thing is just kind of not great. Yeah, and there's sort of my own thoughts. There's like a few more slides, which I think we have time for. We're doing pretty good with time. So I do wonder about like, so maybe I would say that, especially in Finland, like we don't have that many huge tech companies here, or companies where you have like few hundred developers, right? But so I do, while reading the book, I was wondering a bit like sure, you could like apply these to smaller organizations as well in a sense, and I think the product mindset is something that would work in a lot of situations. Like go and talk to your customers, you know, like your stuff is used by someone, and yeah, I would like to see more of this, like really thinking about what the DevOps people do as more about like owning a product and really like providing an experience. Then the customer focus. So this wasn't mentioned in the book, but I think important point is that just because you're an engineer doesn't mean that you understand the customer who's also an engineer. You have to like really go and talk with the customer, understand what they're struggling with, and it's like, yeah, it's also if you just ask for feedback, that's not really enough. They tell you what they would wish for, but if you go and do it daily, you can see they're struggling with something else. Oh.
I would say that a lot of the time the customer doesn't know what they need, and it's your responsibility to help them understand that even. Yeah, I agree. I have some real experience with this as well. Like last year I was working in this platform team, and we spoke with the customers, and they were like it's all good. Like, yeah. I'm like, fuck it isn't, but like, it's hard. Yeah, Victor?
One of the aspects you mentioned earlier is like, yeah, like capturing this metadata, you know, it's going to cost some money, right? Like, if you're actually selling a proper, let's call it proper product to real customers, no product manager, no product owner will be sad about, capturing real usage data in order to understand whether your business is going well or not going well, right? But a thing we lack that, right? I mean, that kind of mentality of like, well, that's already too much of an investment on one hand. And I also believe that as sort of like building platform as a product, we have no marketing people. Yeah. And whenever you are actually, trying to sell a product anywhere, you need to invest in marketing.
Yeah.
So, probably like this event today is the closest to, investing in marketing that you will see in Finland when it comes to, platform engineering, maybe.
Maybe. Yeah. There was like the earlier chapter on the roles and stuff, and I kind of skipped some of the roles that were a bit more like, yeah, you need a manager basically, but like, then in the book it went in a kind of a weird way that, but there's the product manager, like that guy can do everything. He can do the marketing, I guess they're just being realistic and their experience, like, you're not gonna have a marketing expert, whatever, like. But yeah, there's another book that maybe talks about that better. Yeah. Oh yeah. Yeah, I'm so sorry if I butchered the meme, but I couldn't find the original one of these. Someone has sent it to me once. I think I got pretty close. So I guess I do, in one way or another, I do agree with the Terraform code bases thing. Like, there definitely is, like, if you look at the platform definition, it's like self-service APIs, tools, services, support, compelling internal product, like, just like your infrastructure as code repos, your like GitOps repos, and a pull request to those. That's like, maybe that's not all that compelling. Maybe like you're introducing all these tools, and also the Kubernetes manifests and the probably HCL that you use for the Terraform configurations and stuff. Like, you're kind of introducing all that shit to your customers. That's maybe not all that compelling, right? But on the other hand, once you have like enough sort of people that know this can work fantastically well. This can scale like quite a bit, I would argue. But maybe at some point we should hire some software engineers and maybe get rid of some of the DevOps engineers so that we get the perfect balance or something. Oh yeah, and then like Kelsey Hightower, if he says so, then it's true. But I think Kelsey's point here is like, I agree. Like, I've said this to some people that like, when I'm like doing my work at an organization, I want to like focus on really like doing the things I'm good at and like doing my work, and I don't want to have a platform where I'm going to have to like handhold the customers to do something that I already know how to do, because I want to enable them to just do it the way I know how to do it without us every day talking, right? That's where the API comes in. Like, that's like kind of the contract, Would I recommend reading it? So I think the book kind of leaves a lot of room for another book that would be a bit more specific on the technical side of here, or like a bit more like case studies and like actually like this is like real case, real products, or like real tools and stuff, like how it was built. These sort of things are not really in the book, but what the book really focuses on is an important aspect, which is like, yeah, like a lot of people can build, like technically build the product, I mean the platform, but how many are going to really like go and talk to the customers and build the right thing that actually solves the problem? I think that's really the challenge with this. And this is something that's, very much like this book tries to help with that problem. And I think it does a pretty good job with it as well. And then, Yeah, I have some other books here. So I think these are kind of like recommendations from left to right. I've read these ones. So I think like Team Topologies, this is kind of like a foundational book for like platform engineering, because it's like kind of like, I guess, made popular the whole like platform team sort of thing. Then Platform Strategy by Gregor Hope. That's a great book as well. And that's like kind of like similar to this one, bit more sort of technical, a bit different. Gregor's a great author. And then Enabling Microservice Success. This is also, I think, a bit of a platform engineering book, although it's like microservice stuff. But yeah, that's a pretty good book as well. That's it. Oh yeah, and by the way, in Slack we have this special channel, platform engineering. If you want to join, and like, I don't know. Yeah. Well, thanks. I guess now we can take questions.
Yeah, if you yet are not in our Slack, so you can find the link in the end of the agenda. Actually, I have one question. You said that the book wasn't technical enough, but so it wasn't technical enough to say that no Terraform.
Yeah, I mean there was no code blocks.
Yeah. All right. Now I know the definition of a technical book. Yes. I was also thinking that maybe there would have been more readers for the book if they would have in the opening studied the rant of Terraform and not at the end.
Yeah. I guess it was like a test who really makes it to the last page. Must have been.
All right. Any questions? If not, thank you, Mike.
All right. Thanks.
Oh, by the way, hey, wait. Pasi is coming to here also. Say a couple of words.
Okay, just to say thank you for coming. The sauna is warm. We'll be hanging out here for a while. Our support and maintenance guys had a dinner, so they're back here to continue. We'll have a DJ, so you're welcome to stay if you want. But thank you for coming again.